Okay. Hi, everyone. My name is Veena Ne, and I am a high school teacher at Bank College. And I've been involved in 3D printing for quite some time at school level. This year, and in 2022, I also received the Prime Minister's Prize for Excellence in Science Teaching in Australia. So here's a little bit about our story and how 3D printing has helped us in develop STEM in our school. So here we go again, and let's have a look. Do feel free to ask me questions or interrupt or send me questions as we go along as well. Um, okay. So I begin today by acknowledging the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to the Aboriginal and Torres Strait Islander people here today and to the other Indigenous people from where this event is being attended. Um, as you would know, and as many of you from industry would know, that STEM or STEAM is considered to be very difficult, and we are seeing a lot of people not take up or use STEAM or STEM, especially girls. And that is also what we find at school, that the gender ratio in these subjects, and especially in engineering, is skewed in favor of boys. Girls generally shy away from it. The minute you say engineering, they just turn off. And if they do take up science, they do take up science and digital technologies, but they're very reluctant to consider engineering as their career options. And there are students who are not academically oriented, but they feel that they're good with hands-on subjects, but again feel frustrated when navigating tools and other stuff is very hard for them, and sometimes very difficult for them to visualize something and get it done. So all of these students really struggle and to see themselves as a part of the STEM or the STEAM network. This is what we had when I started in 2017 at Bank College. And the best thing that I thought at that time was how to use 3D printing. And I'll come back to it in a minute. So how does 3D printing help with STEAM programs in school, which is the main thing that we want to find out today. So I'll give you some numbers to start off with. In our school, students taking up STEAM electives involving 3D printing at Bank College from years 9 to 12. So these are curriculum-based elective subjects. We have about 150 students each year um, taking part in these subjects, and with more and more girls now participating. And so far in the last 6 years, we have had about 500 students plus who have taken 3D printing at some stage during their school years. And as a consequences of that, we have seen about five-fold increase in students taking up engineering, and including a lot of girls as well. More and more students now routinely use 3D printing from grade 7 onwards through the STEAM Club. So we have an initiative that during lunchtime, students can come and access the 3D printers, provided it is their design, and use it, provided again the designs are appropriate. So students have been using that for a wide range of projects, including their personal projects as well. And that is something that we are increasingly seeing right from grade 7. So why does it help? Why does 3D printing, why are we seeing 3D printing help so much? Now I'll give you a little bit of a story or a backstory. So as I mentioned, when I started in 2017 and I was tasked with setting up a STEAM program at Viewbank College, having used 3D printers in my previous school, I felt that this was a technology that was very novel and very engaging, and it was not threatening. It was something that people would get a lot of fun out of, and I have seen students mesmerize watching their designs come alive on the 3D printer. So the first thing that we did was we installed 3D printers in 3 staff rooms so as to get the teachers excited. And now, when the teachers got excited, they started talking about 3D printing in their classes. And in the following year, when we started putting 3D printing as an elective, we had a little bit of buzz going on with students wanting to explore that area. The reason is that 3D printing, the element of design is gender neutral. You have boys and girls who are interested in design, in drawing, in art, in different forms. And it does not appear to be STEM. And and that is why it allows students of all interests to come and explore it. And when they actually saw that it was able to create uh, and have physical design in their hands in a very short time, it was something even more exciting. So once they started on that journey, it was then easy for us to kind of put some element of solution or problem solving in that, and then make it a little more fun engineering kind of application to it. But we've seen that it has application in all subject areas. We've seen students take make human models for humanities classes. We've seen students do models for science and maths as well. And because they are solution focused, we have found that girls really like it because they can actually do it for a reason. There is a purpose behind it. And so, and it's easy. So it was something that we saw good uptake by the girls of this, and that has translated in growing numbers. And yes, no coding. That was something that a lot of students initially told me that yes, there is no coding. But when I said that what you're designing using Tinkercad is really, creating a backend code. But at the same time, there were students who wanted to do fun robotic projects and mechatronic projects and code. So it was applicable to all kinds of students. um, so this was something that was really good for every student, really. And we have had students from who generally don't engage in other classes come here and get very engaged. So how do we use 3D printing in curriculum to make our students problem solvers and change makers? So we introduced 3D printing and designing as I need to make this smaller, I think. Let me see whether I can, the pictures are not visible. But we started by in year 9 and introduced this elective in year 9 as and the best part is that we engage students as co-designers of the curriculum. So that was also another way that students really resonated with the subject. So we started by researching the current application of 3D printing in all areas to get an idea of the huge scope of this technology. So what I do is I give them a research project and tell them to list as many applications as they can find on the internet, and make a small PowerPoint if possible, and not, or even just document whichever way that they choose to. The idea is for them to discover the applications of 3D printing. Once they know that this has such far reaching applications in all areas, um, they are more geared and excited to take part in the elective going forward. At all times, the challenges are very open ended. The students are really in the driver's seat, and they're also given a little given the freedom to choose what software they would like to use. So if they're absolute beginners and they would like to use Tinkercad, then that's fine. We also take them through Fusion 360 and also teach them the design process, which is modeled on the year 12 subject systems engineering, which I teach. So generally, some an open-ended challenge would be either, as you can see in that picture, make a desktop organizer for yourself. Or recently, I gave a challenge saying make a movable object. Now, a movable object can be anything. It can be a car, small car. It can be a hinge. It can be a clip. It can be anything. And students really like that aspect of being able to choose what they want to make, um, and then go through the design iteration and all of that. And then after we have done that, then we, as I said, we want students to become problem solvers and change makers. And so we give them a group challenge, and again, this is all discussed with them prior to we starting the elective. So we base it on the sustainable development goals, and they have to identify a goal that they want to address and create a solution to that using 3D printing. It is a group challenge, so they take on different roles and different people do different things in the process. But one of the things that I have put in there that everyone would submit one design that they think is a solution, and then the team would decide which is a good design and why. And they have to manage the whole thing. They have to manage the printers. They have to load and unload the filament. They have to troubleshoot the printer or the design or everything. So they are in, as I said, in the driver's seat absolutely from day one. There are some challenges if students misuse or and not misuse, but when they're using the printers for the first time. So you have to kind of help them understand how the technology works, and then take it from there. Uh, in year 10, we take it a bit further, and then we introduce electronics and integrate circuits into it, as well as microcontrollers and 3D printing and laser cutting to create solutions. Again, the focus is on the sustainable development goals or any models they wish to make for the other subjects. And as I said, again, the students develop the curriculum and I provide the framework. So as you can see in those pictures here, what the first one on the left is the one that the students use a microbit to make a water level instrument. So it would tell if the soil had enough water or not. The second one in the middle is the one that you can see the bracket that has been designed for that solar panel, and it uses a microcontroller to tilt the solar panel in the direction of the sun. And the third one, there are some student projects. The challenge was for them to, it is a mix of year 9 and year 10. So some of them are movable, robotic kind of, the ones at the back, and the one in the front, which looks like a flower, was a year 9 project. So the challenge that was given to them initially was to make a lamp that would be um, safe for people in old age homes or people who are older. So they had to think about what constraints they would want to bring into that design. Um, from the year 10, and we go into the subject, as I mentioned, the year 11 and year 12, systems engineering. And this is where students are now, by now, use 3D printing very exhaustively and with great mastery. They are better designers than I am, and they have more time to explore. And they start developing and engineering projects. So, as you can see, there are quite a lot of them there. The the small little keyboard was completely 3D printed. The robotic hand, as you see, is 3D printed. Um, the projects at the bottom are the year 12 projects. Some of them. One of them made an entire rocket system. The second one from the left, the design file you can see on Tinkercad, that one actually has been selected as one of the top projects in Victoria in Year 12 systems. Um, it is a resistor sorter, and that has been done. The gear, there was another project that used gears. It was a touchless elevator, and the student really had a fun time making it. She designed the gears all by herself. So you can see that. And on the very end and the very side, that you can see a small little trolley, if you can make it out. And that was a project called for automated shoe for people with disabilities who cannot tie shoes. So there was an automated zip that went around the shoe, and the student had made a small little tractor or a car, a vehicle, or something pulling mechanism using a 3D printer. So, what has been our 3D printing experience? It is the best way to engage with parents. We have run many workshops for parents and students together, and parents have been very interested and attended enthusiastically, and made their own designs and taken it back. The idea is to upskill everyone in the community as much as possible. We've also run parent and student workshops in year 7 students. Um, and in primary school students, we have started to engage with the local primary schools as well. We have invited experts to give presentations to staff and students, and our staff to encourage staff to learn and use it in their classes. Students have used it in maths to create their own game pieces in applicative maths. So they create an applicative. We have a subject, something which uses an applicative maths focus, and students have created some games, and their game pieces have been designed and printed using 3D printing. Even one of the students created an MC Escher inspired project in maths. We have started an elective not elective, it's one of the main courses in year 7. It's called an art design course, and a lot of students are now in year 7 itself, are learning how to design in using Tinkercad and print as a part of their projects. And one of the two students in year 7 this year used it to create a protein structure for the protein database project, and won a prize there. We have students printing for the science fair or science talent search projects. Students have made drones and underwater drones and sea bins. Girls have used, and I'll say girls because I wish there were boys who were doing this, but we have had only girls do this, jewelry prototypes. But I feel that even if that is the thing, then why not? I wish, as I said, we had both genders using it in similar ways. Creating enterprise. So a student started put up their own setup in the garage and creates prototypes for automotive repairers. Um, Lots of students through the STEAM club come and make gifts, personalized gifts for the siblings, parents, and grandparents. We have used 3D printing as an opportunity to engage with industry and create internship opportunities for our students, as well as creating real life 3D printing challenges that students can take part in. And in fact, I would say our entire STEAM program started with a single 3D printer. I'm going to also let me see whether I can share this a link. Um, and I'm not sure whether it is visible to all of you, but please tell me. Um, is this visible?
Is it can be seen. So, will you want to give me the link and I try to share for you?
It's
Maybe you can select share screen. Yeah, the share screen. So you'll be able to see the whole computer.
um, yeah. I don't think I can share. Mm, that's okay. I'll try again.
So I share for you.
I'll send that link in the chat. Um, hmm. Give me a second, people. Um, and yes, I would give you in a minute. Somehow the share button is not highlighting for me. So let me try this link and see whether you can share for me. Because the button is not getting activated.
able to see the screen?
You're allowed to highlight you're allowed to use the system video, audio for that.
Oh, actually, I on the audio, so it's not okay. Give me a minute. I'm trying to share it again, and if the sound, please let me know whether have it or not. Okay, I
Yeah.
will mute myself for now.
No, there's no sound. Um, that's okay. Um, I will.
The
I
sound
just
doesn't.
wanted to show you through that video, maybe see 3D printing lab a little bit.
Mm.
Um, but yes, that
Uh,
is
for those who are interested, you can just click on the link in the general chat, and you'll view the video as well, right?
so. That's about it from me. Just a minute. I'm going to share my screen for one last slide, which I want. Can you see the screen? Hang on. All right. So I really want to thank everyone for this opportunity, and especially Alex, who I know is here, for encouraging me to present at this prestigious conference. And I want to thank my students and my colleagues for supporting me and joining me for this exciting journey. So thank you, everyone.